Good morning, one and all. My name is Sudhakar. I am teaching about the lathe machine. Right? Yesterday we have learned various types of tool holders. That is, can we recall them? Single point tool holder, multiple tool holder, another tool holder. Right? So these are the types of tool holders we have discussed so far yesterday's class. And also we discussed some types of lathe tools production. In that, we have started with the lathe operations. Already we have learned these lathe operations the previous session, right? With the diagram and based on the tool, we have observed these lathe operations in the yesterday's class. So this is for straight turning operation. Which of the tool we are using? Is it completely made by one material, or edge of the material is made by one material? That has been observed yesterday class. Right? So the straight turning operation. So it is made with a single material. Here for taper turning also it is made with a single material. But for profiling, observe here the edge is made with another material. Right? Here also, if the tool is, what are the advantages of these edged tools? If the tool is broken, we don't replace with another tool by the entire tool. Only we can, the tool is broken, just we have changed this edge. Just we have changed this edge only. So that is the advantage with the tipped tools. Understood? So this is one of the type of edge tool. It is used for turning and axial growing, and for facing operation also we have this entire material is having same material here. Tipped edge is there again, and come to here. So for this operation, similar material, entire body. So like this we have observed in yesterday's class, right? And also we have discussed number of operations in the yesterday class itself. That is turning. For turning operation, we have using only one single material only. Casing operation also, but boring is operation. The tool material is the body of the material is different than the cutting edge. The cutting edge material is another different, and the body is different. But drilling operation, the entire tool material is same. The cutting of material, the body is made with some material, and the cutting edge is made with some material. Threading, for threading also, the body is here. The body is made with another material, and the cutting edge made with another material. Knurling also, we can clearly observe in the knurling operation. The nulls are made with some type of material, and the body which holds that nulls also are made with another type of material. So up to this we have discussed in the yesterday's class, and also we have concluded that number of types of tool holders, right? In that multiple tool holders, single point tool holders, knurling tool holders, right? Drilling tool holders. So different types of tool holders we have discussed so far, and work holding devices also we have discussed so far, right? So up to now we have discussed about the lathe machine and its parts and function, and constructional details of lathe machine, and what are the operations we are performed on the lathe machine, and what are the work holding devices while doing the lathe machine operation, and what are the taper turning methods, and what are the tool holders. These are discussed so far, right? And now we are moving to the lathe tools, the tools which are doing the operation. We are going to discuss about them, right? So we have different types types of tools. Before going to discussing about the lathe tool geometry, first of all, we have to discuss about the types of tools, right? After that, we are going to discussing about the types lathe tool geometry. Now, we are moving to discussing about the types of tools, right? Types of lathe. So, in the diagram, we have observed different types of tools, right? Some of them are made with a single material, and some of them are made with two different materials. The body is made with another material, and the cutting edge is made with some material. So, these are observed in our diagram, right? The cutting tools used in a lathe operation is single point cutting tool, right? We are already learned this. Single point cutting tool means it is having single point cutting edge, right? With that cutting edge only we are doing the operations, right? In a single in lathe machine, generally we are using types of tools are single point cutting edge tools. Why? Because single point cutting edge tools, because they are having only one cutting edge, right? That's why these are called single point cutting tools. That's why single point cutting tool. We call it as single point cutting tool. So observe here, every tool is having only one cutting edge only. Means having only one cutting edge at the end. So this is the body of the cutting tools, and this portion is having cutting edge. If the body is made with two different materials, if the tool is made with two different materials, but at last the cutting edge is only single point. That's why they are called as single point cutting tools. The body is made, the entire tool body is made with the two materials, right? The body is made with some material and the cutting edge is made with some another material. But the cutting edge is having only single point. That's why it is called as a single point cutting edge tool, right? So because it is different with multiple cutting edges, right? We will see what are the multiple cutting edges tool in the next slide, right? So actually, lathe machine tools are differed by two different cutting tools. One is single point cutting tool, that is example lathe tool, and the second one is multi-point cutting tools, example drill bits. Okay, the single point cutting tool is lathe tool and multi-point cutting tool drill bits. These drilling operations we have observed in our first year workshop technology. But there we are not discussed about the cutting edges. Just we have discussed about the operation. What are the drilling operations? Drilling, boring, reaming, etc. This type of internal tapping. This type of operations we have discussed in our drilling chapter. But we have not discussed about the cutting edges, right? Here in this lathe machine, we have discussed about the types of cutting edges, right? The tools which are having single point cutting edge, they are called as single point cutting tools. The tools which are having multiple cutting tools, multi-point cutting tools, multiple cutting edges, they are called as multi-point cutting tools. A single point cutting tool, we have done that is example for lathe tool. In the operations, we are in the operation itself, we have observed that single point cutting edge, multi-point cutting tools, the drilling operation. If we recall in from the first year, we have observed that is having the drill bit is having multiple cutting edges, so they are called as multi-point cutting tools. Types of lathe tools. Single point cutting tools, we are having different types of single point cutting tools. According to the direction of feed, we are having different types of single point cutting tools, right? Those are right hand tools, left hand tools, right? So, by standing before the lathe machine, our right hand side is at lathe tailstock side, and our left hand side is at headstock side, right? So already we learned about the centers that tailstock is at the right center, and headstock is at the left hand side center, right? And that the headstock side is called as a live center, and the tailstock side is called as a dead center. Already we have learned so far, right? Based on that, according to the direction of feed, if we are giving the feed from right to left, from tailstock to headstock, that in that for that operation we are using right hand tools. If we are moving our cutting tool from left hand side to right hand side, that is headstock to tailstock side, that tools are called left hand tools, right? The right hand tools are having cutting edges on the left side. Why? Because the left side, because we are moving our cutting tool from right hand to left hand, right hand to left hand. So the operation is performed at the left hand side of the cutting edge, left hand side of the tool. So the operation is performed at the left hand side of the tool. That's why the cutting edge is formed at the left hand side. But for right hand tools, the cutting edge is formed at the left hand. For left hand tools, the cutting edge is formed on the right hand side, because we are moving our cutting tool from right hand side to left hand side, right? So the cutting edge is formed in the right hand side. So that's why the operation is performed from left to right. From right to left, the cutting edge is at the left side. From left to right, the cutting edge is at the right side. So these are the single point cutting tools according to the direction of feed. Right hand tools, left hand tools. Types of lathe tools, we have already discussed the right hand tool. Cutting edge, the metal from right to left. Here the cutting edge is fed on the metal from right to left. Cutting edge on the left side. For right hand tools, the cutting edge is on the left hand side. Left hand tool. Cutting the metal, cutting the metal from right to left. You can easily tell that cutting the metal from right to left. The cutting edge is on the right hand side. The cutting edge is on the right hand side. Here, observe here. I already told this is the right hand side. It is the operator here. It is at right hand side and it is at left hand side. It is headstock and it is tailstock at right hand side. Tailstock is there. At the left hand side, headstock is there. So the operation is performed with the right hand tool. We are moving our carriage or our composite to right to left. If we are doing left hand, if we are doing left hand tools, we are moving our carriage from left to right, right? So that's why for right hand tools, the cutting edge is at the left side. For left hand tools, the cutting edge is at the right side. This is for right side, this is for left side, and this is for right side, right? And observe here, different types of tools are there. So this cutting edge is formed here only. Here the cutting edge. These are the tools for. This is the tool for left cut. So for left cut means it is from left to right. So it is the right cut from right to left. So here the cutting edge is there. Here cutting edge is there. So this type of cutting edge is used for roughing operation. If we are cutting with this cutting edge, that cutting edge is used for roughing operation, right? And the tool is having this type of face also, right? Inclination face. If we are using this cutting edge while doing the operation, if we are using this type of operation while doing the moving, that is called finishing operation, right? We come to here. Here, the cutting edge is formed here. The cutting edge is formed here. We are engaging with this tool. That operation is called side-facing operation, right? For both operations, left hand, right hands, it is called as a nose radius, right? So observe here, side-facing. So it is used for side facing operation. For right cut tools, it is for finishing and it is for roughing. See, these are indicates the cutting edges. These arrows indicates the cutting edges. So for left hand tools, the cutting edge is formed like this, and based on the operation, we are using this type of geometry. And for right hand tools, we are having different types of cutting edges, and based on the operation, we are using different types of cutting edges, right? And classification according to the purpose. We can classify according to the purpose also, based on operations like facing, parting, etc. Right? In the figure itself, we have observed that for workhorse operation, we are using these cutting edges A and B. So this indicates the cutting edges of the tool. For finishing cuts, we are using these cutting edges, these cutting edge. And for parting cuts, here we are using this cutting edge. And for parting cuts, the material is made with some material and the cutting edge is made with another material. And it is this type of tool is used for 60 degrees threading, 60 degrees threading operation. So in the before classification, based on the classification according to the direction of field, according to the direction of field, and this is for according to the purpose, and based on the operation, we are having different types of tools, right? And the third method is classification according to the method of manufacturing. Based on the manufacturing also, we are using different types of lathe tools, forged or solid tool, tipped tool. We have observed that we have already discussed that the forged tool and the tipped tool. So this is the single point solid tool, and that means its entire body is made with the single material only. Solid material means based on the manufacturing operation, right? We have observed in the yesterday's class different types of operations for turning, grooving, drilling, pouring, different types of operations we have observed. These are all called the manufacturing operations. So based on that operation, we are using different types of tools, right? So here also one of the classification is according to the manufacturing process. That process is based on that process. We are having different types of tools. One is solid tool, and the second one is the tipped tool. The solid tool is having the body is made with single material itself. Entire body is made with single material itself. And the tipped tools are made with different types of tools, right? Different types of materials. This entire body is made with another material. And observe here, this is the material made with this is the cutting edge, and this cutting edge is made with a different material. Observe here, this cutting edge is made with different material. That's why this is called a solid tool, and this is known as the tipped tool, right? So these are the lathe tools according to the types of lathe tools. Right? Actually, we can again repeat it. Machine tools are single point tools, and lathe tools, example, multi-point cutting tools, example, drill bits. Classification of single point cutting tool according to the direction of feed. According to the direction of feed, we are having a single point. That means according to the direction of feed, the right hand tools and left hand tools. If the tools having right hand cutting edge, they are used for left hand tools. The tools having left hand cutting edge, they are used for right hand tools, right? So this is according to the direction of feed. And another type is according to the operation purpose, according to the purpose, that is for facing and parting operation. Based on operations like facing and parting operations, we are using different types of tools, right? Now we are another type of material tools, that is the classification according to the type of manufacturing. Forged or solid tool, tipped tool. The body is made with a single point tool. That body is called a forged tool. If the body is made with two materials, so one body is made with another material, and the cutting edge is made with another material, that type of tools are tipped tool. So these are the lathe tool types, right? These are the lathe tool types. Now we are going to discussing about the lathe tool joint. Lathe tool geometry, right? So observing a term used in lathe tool geometry, we are having different types of edges here that will be discussed now. So this is the lathe tool geometry, right? So this is our tool, different types of views, right? The entire our lathe tool is here. Different types of views are here. Front view, top view, and side view. So we are observing different types of geometry on our cutting tool, right? So observe from here, it is a shank, this is face, and here is known as end cutting edge angle, and here this angle is side cutting edge angle, right? And this part is called nose. This part is called nose. Come to here, again it is a shank, and this part is called flank. This is a base, so our tool is fixed on the tool post with this part. So we can tell that it is a front view, and this is a top view. By top of the tool, we can observe. By top view, we have observed these parts, and this is a right hand side view. This is the right hand side view. Here, it is a shank, flank, base, and back rectangle, cutting edges. These both are cutting edges. And heel, this part is called heel. And the angle between these two parts is called end relief angle. End relief angle, right? And this is side rectangle, side relief angle, and it is also called as a heel. So this diagram shows the different type views of the tool, and by the views we are observing different types of tool geometry, right? And this is the front view, and this is the top view, and this is the right hand side view. And this part, this base part, with this part, the tool is fixed on the tool holder, and these are the cutting edges and end cutting edges and flank nose. So side right angle, side cutting edge angle, end cutting edge angle, end relief angle, K. So these are the terms we have to know clearly what is base, what is flank, what is shank, what is base, what is side right angle, what is side relief angle. That will be discussed now. First of all, we are discussing about the shank, this part. Shank is a solid part. Shank is a solid part. It is called as a entire body of the tool. Shank is a solid body of the tool or part on one end of which the cutting edge is formed. Right? The figure itself, we are observing where the shank is situated. The entire tool, entire body, the half, more than half percentage, the shank part is there. So this is the body of the tool. So it is called as the body of the tool or part one part on one end of which the cutting edge is formed. Face. Next, face. The face is the side to the shank part. Face is the adjacent side to the shank part. It is the top surface of the tool between the shank and the point of the tool. I have already told that this is the top view. This is the top view of the cutting tool. That's why face is called top surface of the tool. Right? Top surface of the tool between the shank and the point of the tool. Between the shank, this is the shank, right? And the point of the tool. In between our faces, the tool face is situated. Right? It is the top surface of the tool, and it is in between the shank and the point of the tool. That's why it is situated at the top surface of the tool, and the face along this face, the chip flow, chips, which are, while doing the cutting operation, chips are formed. The chips are different types of chips are there, continuous chips and discontinuous chips, based on the material, based on the operation, based on the types of materials and the properties of the materials. These chips are formed. Continuous chips and discontinuous chips, and continuous chips or discontinuous chips. That the chips, while doing the operation, flows along the face of the tool. The face is situated at the top surface of the tool, and it is in between the shank and point of the tool. And while doing the operation, the chips are flow along this face of the tool. Point. Here, wedge shape proportion. This is the point, and this one is the point. Right? So wedge shape proportion where the face and flank. So top surface is face, and the flank is here. These two faces are made here. These two faces are made here. So this is called a point. This is called a point. Right? This is called a point. And the cutting part of the tool, this wedge shape is also called as a cutting point of the tool. You can call it as a cutting tool point, and also called nose for round nose tools. So this is, we are called it as a nose also. For round tool, for round nose tools, we can call it as a nose. This point is called. Point is wedge shaped portion where the face and flank of the tool meet. Cutting part of the tool, also called nose for round nose tools. Also called for round nose tools. Flank. The flank is the adjacent side to the shank. Is the portion of the tool which faces the work, right? So here is one of the important point is it faces the workpieces. So while doing the operation, it is the touching to the workpiece. It is touching to the workpiece. It is faces the workpiece. So while doing this operation, the cutting edge is here, the point is here, and the operation is performed. This flank is faces the workpiece, and it is adjacent to the face of the workpiece. Flank is adjacent to the face of the workpiece, and also surface the stitch adjacent to end and below the cutting edge. Surface adjacent to and below the cutting edge is flank, right? Flank is adjacent to the cutting edge and below the surface, and the portion of the tool which faces the workpiece, they are calling it as a flank. Right? Base. I have already told you that the base is the surface of the tool that shank which bears against the supporting tool holder. Where the base is there, the diagram shows here is the base, right? So this base uh, bears against the supporting tool holder. This base against the supporting tool holder. Surface of the tool shank. Surface of the tool shank. This is the surface of the tool shank, right? Surface of the tool shank, which bears against the supporting tool holder. But this base is on the tool holder, right? So the tool is from the front view, it is observed like this, right? From the top view, it is observed like this. So this base is on the tool holder. This base is on the tool holder while fixing the tool in the tool holder, right? This side is on the tool holder side, right? The surface of the tool shank which bears against the supporting tool holder. Understood? And Yeah, so now we have discussed about the shank, face, point, base, and flank. Five parts. Heel. Here is the heel. Portion at the bottom of the tool where the base and flank of the tool meet. Portion at the bottom of the tool where the base and flank of the tool meet. So it is the bottom of the tools. These are the bottom of the tools where the base and flank of the tool bit. This is the flank base and another base is, and this is the base here. So the base point and this is the flank base point. So these points are meet here. So this part is called heel. This part is called heel of the tool, right? Shank, face, point, flank, base, and heel. These are the parts of the tool. These are the parts of the tool. Now we are going to discussing about the different types of cutting edges and the different types of cutting edge angles. Different types of cutting edge angles. Nose radius. Nose radius. Curve formed by joining the side cutting edge and end cutting edge. Curve formed by joining the side cutting edge and end cutting edge is called nose radius, right? Here, you can observe here. This is the side cutting edge and end cutting. Side cutting edge and end cutting edge. Like this, uh, we are getting this nose radius, right? Curve formed by joining the side cutting edge and end cutting edge. Nose provided with a radius called nose radius. The nose is having denoted with the nose some radius. That radius is called a nose radius. Nose provided with a radius called nose radius, right? This is a curve formed by joining the radius side cutting edge and end cutting. Side cutting edge and end cutting edge. Lathe tool geometry. Sharp cutting nose weakens the cutting tip, right? Nose radius provides sharp cutting nose weakens the cutting tip, right? Nose radius provides gear strength, prolonged tool life. Nose radius provides greater strength, prolonged tool life. Tool with too large nose radius leads to charter. These are the defects that will be discussed in the next classes. Sharp cutting nose weakens the cutting tip. The cutting nose is very sharp. The cutting tip will be weakens while doing the operations, and the nose radius provides greater strength, prolonged tool life, and tool with too large nose radius leads to charter. Too large nose radius leads to the charter. Cutting edge. Portion of the face edge along which the chips separated from the work. That is the cutting edge. And side cutting edge. Edge formed by the intersection of face and side plane. We observed in the diagram itself. The cutting edge is the portion of the face edge along which the chip is separated from the work. Because the face part we have observed, along with the face part, the chip is flowing. The chip is flowing while doing the operation. Based on similar way, in the similar way, side cutting edge formed by the intersection of face and side plane, right? So this is the actual cutting edge formed while doing the operation. The actual cutting edge while doing the operation, edge formed by the intersection of the face and the side plane. It is the actual cutting edge. And end cutting edge formed by the intersection of face and end plane. Edge formed by intersection of face and end plane, right? So these are the cutting edges. One is the cutting edge and second one is side cutting edge and end cutting edge. The edge formed by intersection of face and end plane, we can call it as the end cutting edge, right? So these are the parts, geometry of the lathe tool, that is face, flank, etc., and the cutting edges shanks, right? Leaf angles, nose, heel points, right? So these are the cutting angles of the cutting and parts of the tool, right? So now we are moving to discuss about the angles, principal tool angles, right? So far we have discussed about the parts, body parts and edges, right? And now we are moving to the principal tool angles. In this principal tool angles, we learned two or three or four angles today, and the remaining will be discussed in later classes, right? And this first one, right? Just observe in the figure what are the angles. This is the back rake angle, and it is the side rake angle. Here also side rake angle, end cutting edge angle, and this is the nose, end clearance angle, end relief angle, side cutting edge angle. Right? Observe once again back rake angle, end clearance angle. This one total end clearance angle, and this one end relief angle. This is the side angle, and this one is the side clearance angle. This one is the end cutting edge, and this is the side cutting edge angle. Right? In this, different types of tool angles are there on our cutting tool, like body parts and cutting edges. Right? That today we are going to discussing about the rake angle and back rake angle. Right? The rake angle is where the rake angle is situated. Just observe here. Where is the rake angle? So, rake angle means back rake angle and side rake angle. Right? Two types of angles are there, which is called rake angle. The angle between the tool face and plane parallel to the base of the tool. Angle between the tool face and a plane parallel to the base of the tool is called rake angle. In that, we are now discussing about the back rake angle. The angle between the face of the tool and the base of the shank. Here, we are observed our back rake angle. This, the angle between the face of the tool. So this is the face of the tool, that is the top surface. Here, top surface, face of the tool, and base of the shank. Base of the shank is measured in a plane through the side cutting edge. It is measured with the plane through side cutting edge. That angle is and it is at the right angle to the base, and it is right angle to the base. So this angle is called back rake angle. This angle is called back rake angle. Here we are observed that back rake angle is here. Angle between the tool face and a plane parallel to the base of the tool is called rake angle. The back rake angle, the angle between the face of the tool and base of the shank measured in a plane through the side cutting edge and at right angles to the base. In this back rake angle, two different types of rake angles. Positive rake angle and negative rake angle. The tool faces downwards from the point towards the shank. That is called positive rake angle, and the negative rake angle. The cutting edge faces upwards towards the shank. Upwards towards the shank is called negative rake angle, right? Positive rake angle means tool faces downwards. Tool faces downwards from the point towards the shank. Negative rake angle. Cutting edge faces upwards towards the shank. Upwards towards the shank. So this is the back rake angle, right? The next one is the side rake angle. side rectangle, the angle between the base of the tool. So where the side rectangle is situated here, we are observing side rectangle. The angle between the base of the tool, shank, and the face of the tool. The angle between the base of the tool and the face of the tool. This is shows the cut's side view. So we are observing here side rectangle. The angle between the base of the tool shank and face of the tool, side rectangle is formed. Measured in a plane perpendicular to the plane through the side cutting edge and right angles to the base. Measured in a plane perpendicular to the plane through the side cutting edge and right angles to the base, that is called side rectangle. Understood? So in this also we are having a positive side rectangle and negative side rectangle. Tool face is sloping upwards towards the side cutting edge. Tool face is sloping upwards towards the side cutting edge. Negative right tool face is sloping downwards towards the side cutting edge. It's called side rectangles, right? So these are the angles in the cutting tool. The remaining angles will be discussed in the later classes, right? And tomorrow again in the next class I will again repeat these angles also. Now go into close this session. What we can we recall what are the things we have learned so far, right? So before going to close today's class, let us summarize what we have learned so far. That is, single point cutting tools are used in general works on lathe, right? That have been discussed in today's class. And lathe tools may be classified according to direction of feed, purpose, capture, purpose, and the method of manufacture, right? Now, based on direction of feed, we can tell that the right-hand tools and left-hand tools. For right-hand tools, the having the cutting edge at the left-hand side. For left-hand tools, the cutting edge is at the right-hand side. Right. So these are the uh, tools based on the direction of feed. And the purpose. Purpose means what are the operation is going to be done. That is facing operation, or parting of operation, or cutting of operation. Right. Based on that operation, we in these tools are divided, and the method of manufacturing. Manufacturing methods like solid tools, and based on manufacturing methods, we can divide it solid tools and tipped tools. Solid tools and tipped tools, right? And after that, we have discussed that lathe tool geometry. In that, we have discussed that the body parts. First one is the shank. That is the main body of a solid tool, and this of tool is kept in the tool holder. Right? So the percentage of this body of the in the body, the shank is replaced the main body of a solid tool, and this part of tool is kept in the tool holder. Next, face. Top surface of the tool between the shank and the point. Face is the top surface of the tool between the shank and the point. The point. Wedge-shaped portion between the face and flank of the tool. These are all observed in our lathe tool geometry. Shank is the main body of the part, and face is the top surface of the tool, and it is between the shank and the point is the wedge-shaped portion between the face and the flank of the tool. And the flank portion of the tool which faces the work. Portion of the tool which faces the work. Base surface of the tool shank which base against the supporting tool holder. Base is the surface of the tool shank which base against the tool holder. And heel bottom portion between the base and flank. Right? And also including that cutting edges, cutting edge, side cutting edge, and end cutting edge. These points also discussed in today's session. These are all under the category of lathe tool geometry, including apart from these some angles also we have discussed today. That is side rake angle, right? That is rake angles. The rake angle. In that rake angle, we are having two different types of angles: side rake angle and back rake angle. In side rake angle also we are positive rake angle and negative rake angle, and back rake angle also we are having positive rake angle and negative rake angle, right? So these are the points we have discussed in this today's session. Based on this, we need to do some quiz questions, right? That is, left hand tool on lathe can cut the most efficiently when tool travels from left to right end of the lathe bed, right? So the name itself left hand tool. So that's why the from right hand to left hand of the lathe bed is the answer. We have told that, not thinking, we can directly tell that the left-handed tools are moving from right to left end and lathe of the bed. So that is the left-hand tools on lathe can turn most efficiently when tool travels from left to right. Sorry, left-handed tools moving from left to right, but here the confusion is where the cutting edge. The cutting edge is at the right hand side, right? Left-hand tools are moving from left hand to the right hand, but the cutting edge is formed at the right hand. Crater where takes place in a single point cutting tool, right? Planet, cyber, base, tip, base. And frequently asked questions, draw the line diagram of single point tool and show the silent point of tool, right? Now, by this, I am concluded today's class. Tomorrow we will be discussing about the